Chapter 19, Testing Hypothesis about Proportions. For hypothesis testing, there are two hypotheses. The null hypothesis, which is noted as H naught, is P is equal to some hypothesized value. This is the starting hypothesis to be tested, and it's null because it assumes that nothing has changed. The null hypothesis is never accepted or declared to be true. The null hypothesis is either rejected or not rejected. Our other hypothesis is the alternative hypothesis, which is noted by HA, and it contains all the other values of the parameter that we consider plausible if the null hypothesis is rejected. Now we can have a two-tail alternative where P is not equal to the hypothesized value, or a one-tail alternative where P is either less than or greater than the hypothesized value. The p-value is the probability value on which we base our decision to either reject or not reject the null hypothesis. A low enough p-value leads to reject the null hypothesis. Higher p-values lead us to not reject the null hypothesis. The test statistic is a random variable that is calculated from the sample data. It is used to determine whether to reject the null hypothesis. It compares the sample with what is expected under the null hypothesis. The reasoning of hypothesis testing. The hypotheses, the null hypothesis is the claim that nothing is different. We must gather enough evidence to reject it. It specifies a particular parameter value to use. So for our model, we have to check our required assumptions. So once again, the independence assumption, and we check our randomization condition and our 10% condition. For the sample size assumption, we have to check our success-failure condition. In this chapter, we will be performing one proportion z-tests. For the mechanics of our testing, the goal is to determine how surprising sample data would be if the null hypothesis were true. The p-value measures the probability that our observed value or a more extreme value occurs if the null hypothesis is true. If the p-value is small enough, then we reject the null hypothesis. For our conclusion, we must state why we are either rejecting or not rejecting the null hypothesis, and we always state the conclusion in the context of the problem. For p-values and decisions, how small the p-value has to be to reject the null is context dependent. There is no universal value. For the purpose of this class, you will be given a significance level, also known as an alpha level, to test against. Example, alpha equals some specified significance level.